Hello, Science 9. Let's get started on our activity today. In your Google Classrooms, you will have a current and voltage lab. Today, I'm going to walk you through to collect your data through your observations. So you will not be setting up this lab. I will set it up for you, but you will collect the data and then make your analysis. There's two parts to this lab, so we will skip between the two, and you can do the questions and submit them later. So in every lab, we have to follow what we would call the scientific process. We have a problem. We are going to question how to solve that problem. We're going to give a hypothesis stating what we think is going to happen. So our problem today is, does electric current flowing through a circuit change at different points within the circuit? That's what the word vary means. Is it different at different points? What I would like you to do is make a hypothesis. You are going to predict whether that current at points B, C, and D will be higher, lower, or equal to the current at point A. So here is point A. If current is running through point A, will it be the same, equal, lower, or higher? I guess the same and equal are the same thing. Equal, lower, or higher as B. Will A be equal, lower, or higher than C and D? So you're going to make those predictions right now before we even start the lab. What do you predict? All right. I'm going to set up this lab quickly for you, and we're going to go through and we're going to collect our first set of data. So here is my beautiful lab, and you've already learned a little bit about circuits, so you're going to learn how to set one up kind of quickly. If you are wanting to set up a lab yourself, or if you're wanting to play around with this, you can go to PhET Colorado, which is where we get most of our labs, and you can just type in construction kit, I guess circuit construction kit, and you will be sent to a site that you can use these. So here I'm going to start building my circuit using my source. So my source is what's giving me the energy. So those are my batteries. I'm going to add in a conductor. So remember, wires are what conduct the moving electrons around it. I'm then going to add in some sort of control. So my control is my switch. It allows me to turn things on and off. Okay, so I don't want that on yet. Through my conductors, I'm going to hook up a load. So a load is what converts the electrons and uses it and slows them down. So I'm going to use two light bulbs today, and I hook them into my conductors like so. And I have my circuit. So here's my very first circuit. If I want to test it to make sure it's flowing properly, I just turn it on. And there we go. So we're going to get started. We're going to take out this lovely current or ammeter right here. And what we're going to do is we're going to measure the amps flowing around, so current. In your lab, you have this table. What I would like you to do is we're going to start here with the switch open. Now, most of you can probably predict, looking at this picture right here, what my results are going to be. There's no movement of electrons, so if I hover over point A, no current is moving. Makes sense? There's no electrons moving. So if I move to point B, again, zero. There's no current. Why? The switch isn't closed. I think you can guess what happens at C and what happens at D. There we go. So as you can see, with the switch open, there's no movement of electrons because we've broken that connection. So we have no current flowing. I'm going to close my switch. I now have movement of electrons. So now we're going to see and predict what happens at point A, B, C's, and D's. Okay, so here's point A. I have a current of 0.90 amps. So in your table, you have listed zeros all the way down. Here is our very first location with our switch closed, so it's 0.9. Go back to our lab. At point B, we have the same current. At point C, we also have the same current. At point D, the same current. So your table should now be complete with all of the answers for open switch and all of the answers for closed switch. At this point, you can pause the video and start your questions if you want, or you can continue on and go back to your questions. I'm just going to quickly speak on the questions to help you understand some of the wording. So it says, compare the electrical current flowing out of the battery and into the battery. Suggest any explanations for your observations. So you are looking at A and D. Tell me what you see and why you think it's like that. Okay, compare the current on either side of the bulb, B and C or points C and D. Tell me, compare it. Tell me what they are. Okay, how did opening and closing the switch have an effect? Okay, now it says for an electrical current to flow, what two conditions must exist? So if you think back to the circuit I created right here, what two things do I absolutely need in order for electrons to flow? I want you to think about that, add that into your answer. What do you predict will happen to the strength of the current if another light bulb is added or if a light bulb is removed? So remember the strength of the current. I want you to think about those as well. Put your answers down. So now we're into part B, which is talking about voltage or the potential difference across different parts of the circuit. Again, we're going to do a little bit of a hypothesis. I want you to decide, it says examine the diagram below, and B, C, D, and E will be higher or lower or equal to A. So again, you're using A as your constant and making a prediction if they're higher, lower, or equal. Now, the nice thing is my beautiful circuit is already made because that is the same part here. So I'm just going to remove this, open my switch, and move this out of the way. I'm now going to need my voltmeter. So the very first thing I need to do is I need to hook up my voltmeter to point A, which is on either side of the battery. Now we have to be careful because you'll notice my voltmeter reads a negative number. And that is because I have it hooked up backwards. So all I need to do is switch the prongs around and I should get a positive reading. So I'm going to turn this on and you can see that I have a voltage of 18 volts at point A. So in your location, you're going to put 18 volts because we're using the nearest whole number. I'm now going to go to point B, which is across the switch. So across the switch is right here. So I'm going to hook this up to this side and this to this side. And I have 0 voltages passing through my switch. B, that was B. So now we're going to do C, D, and E. So C is the very first light bulb. Look it up. You can see I have 9 volts. That's for C. D, also 9 volts. So that was each light bulb separately was 9 volts. Now I'm going to include both light bulbs in. You can see that it's 18 volts. So if we were to go back to our chart, we had 18, 0, 9, 9, 18. Okay. So now you need to do a little bit of an analysis. We need to talk about what is supplying the electrical energy. What is the source? What uses that energy? What is the load? Compare the differences across the battery and across E. So you're telling me, are they the same, different, or equal? Okay. And then in number 3, it says, how does energy provided to the circuit compare to energy used by the circuit? Okay, so is it the same? So is A giving us what voltage and is E using it all or is it using less of it? Because remember, the loads are both using it at the same time. Okay, it says, how does the potential difference across one light bulb compare to both? Now I say be specific because I want you to explain to me what is the difference between one light bulb to 2? How do they change? Then it says, how does the potential difference across point E change when the bulbs were removed and suggest why? So all that is saying is if I went back to my lab and I took away this bulb, what's going to happen? What do you think is going to happen? Let's look. This used to be just 9 volts. Now it's 18 volts. Okay. So in here, you said, suggest what is going to happen. Well, I just showed you why, but why do you think that is? Why do you think as soon as I removed a light bulb, now 18 volts is coming out of that light bulb instead of just 9? And then you're going to do a little prediction here. I have the same setup, 2 batteries, a switch, but I added 1 more light bulb. So this is 18 volts. It's asking you, what do you think it is all the way across? What is the voltage here? But what do you think each one of these is? So ladies and gentlemen, you're going to answer the questions. And when you are done, please turn in your lap. And I hope you have a wonderful day.